how we identify whether or not a chemical or physical change has occurred. So what were some signs? Y'all just gave me one of them. What was a sign of a chemical change? Fizzing and foaming, and that is the release of a gas. All right, what were some other ones? Heat, yes. Does that mean I put it on a burner and I warmed it up? No.
It's heat. It mixes and makes heat.
Yes, when you pour those two things together, it creates heat. What's another one?
Production of color. Order.
Yes, change in color. What did you say?
Odor.
Odor. So color, you had two colorless substances. You pour them together and they change color. Odor. Say I have two odorless substances. I pour them together and all of a sudden they have a stinky smell. All right, those are all what type of properties that we're observing a change in?
Chemical.
Physical. Color. Odor. What's the first one? Fizzing. That's
Heat.
yes, heat. All right, talking about temperature. So those are all physical changes that let us know that something is occurring. So if we were to combine hydrogen gas, 2H2 plus O2 to get water, can I actually see this occurring? No, I can't see that happening. All right? If I look at what was actually happening in the lab the other day, you had copper bromide and aluminum. And you yielded aluminum bromide plus copper. And now this isn't balanced like we're going to do later. But essentially, this is what you produce. You saw a color change. It went from shiny gray to what? Brownish red. Well, what color is copper? Red. So that was what you were producing. You were producing copper. All right, so that's why you saw that reddish copper wire colored product that ended up solidifying and precipitating in your reaction. All right, could you see these molecules moving? No, but the foaming, the heat, the smell, y'all had almost every possible sign of a chemical change that told you this was happening. Right? So a lot of times it's physical changes that let us know we had a reaction. Right? So when we have a chemical change, that means a chemical reaction has taken place. All right, so what you're looking at here is the reactants and products. In every chemical equation, you have reactants and then you have products. Your reactants react to produce the product. Remember that. Your reactants react to produce the product. All right, so your reactants are like your ingredients, your eggs, your batter, your flour, your chocolate chips, whatever you're throwing in, all right? And then your product is the cookie at the end, all right? So what are you combining together to create the desired product, all right? If you're making something, say you go on to have a great invention, all right? And you're making it, your reactants are all the things that you need in order to produce the product you have designed. Reactants react to produce your products. So if we look up here, I have H2. Here's two H's together, and I've got two of those. So 2H2 plus O2, and this is the example I just gave you, yields 2H2O. Reactants and products. All right, so if we look at this equation.
So are all chemical changes
Yes, all. If there's a chemical change, there's a chemical reaction. All chemical reactions.
What's in the quotes for?
You will see if something physical will tell you that the chemical is happening. Yes.
What's in the quotes?
There's not one. Just say product. Put a product in. Are we good now? Raise your hand if you still need a second. All right. So what are our reactants here? And what are our products? Well, our reactants are where? Yep. Go ahead.
zinc. I don't know what S is. Sulfur.
Nope. Solid. It just means the state of matter. We'll talk about that as we go on.
Gold, nitride. Where'd you get gold?
Not gold.
Or silver.
Silver.
Silver nitride.
Trite.
Nitrite.
Yes, nitrate. All right, zinc and silver nitrate are reactants, and they react to produce what?
Zinc nitrate.
And silver. Good job, guys. Yes. So your reactants are on the left, products on the right. Reactants are always what you start with, that tail end of your arrow. All right, you can just draw an arrow down into your blanks.
So zinc, silver nitrate.
Zinc and silver nitrate produce zinc nitrate and silver. You can just draw an arrow from the ones above, all right? Being able to identify your reactants and products. Well, it's written right above it. You don't have to rewrite. All right, so there's 5 general types of reactions that we're going to talk about today. These are what you're going to see as you're doing things in the lab. And these are the reactions that are taking place. So, starting out with synthesis. What does the word synthesis mean? Like, if you just think of English class and you're synthesizing something, what does it mean? You got a bunch of points and you're like, synthesize these 5 points.
Put them together.
Put them together, like bring everything together. So what do you think is going to happen here? Yes, combine. What do you think is going to happen here?
2 chemical changes come to 1.
To 1. 2 chemical reactants come together and form 1 product. Right? And we've got some of like celebrity examples that help you see it. 2 things separate come together as 1. All right? 2 separate elements come together to form 1 compound. So if you look here, A plus B equals AB. And then you have copper combining with oxygen to combine and make copper oxide. So that's when you see, like, that's what's happening to the Statue of Liberty. All right, that's why it turned green. All right, and then decomposition. If you say something decomposes, what's happening?
Breaks down.
It breaks down. Okay? So one reactant, you started with something whole. Like when you think of decomposers, think about like biology class. When you talk about when something dies and it breaks down. And you'll talk about like earth science class, when you talk about decomposers. And it takes something whole and breaks it down. Roadkill on the side of the road, right? Maggots come and just the body just decomposes eventually. Same thing here. One whole thing decomposes into multiple parts. All right? So the example there is soda and the carbonation that's coming back out of that as it fizzes. That is the release of that carbon dioxide back into the air. So that's your example. Your celebrity example. All right, Shannon Tatum. And then they were together as 1. Right? So started out as 1, separated apart into multiple. Right? 1, and they separate apart. Hopefully that gives you a good little visual for what's happening. What?
It's the opposite of synthesis.
Yes, the opposite. Synthesis starts with 2 and ends with 1. Decomposition starts with 1 and ends with 2. Just think about what the English word tells you is happening, and that's literally what's going to happen. Bryce.
So synthesis, they make a product, and decomposition, it's the product.
Right. I mean, they have a product, but it's multiple products. Look, 2 or more products. You started with one thing, and it's split apart into many. Think about it as a body decomposes. What happens? Yep. Starts out all together whole and breaks apart. All right. Instead of a whole cookie, you've got little pieces of a cookie. All right. Single replacement. Single replacement. What do you think? What do you think is going to happen? Don't just read to me what it says. What do you think is going to happen?
Element replaces.
What does replacement mean? One of the things is going to get switched out. Good job, Lily Kate. All right? So, something's going to get replaced. All right? But only one thing is going to get replaced. So, they switch out, and something is left single. So, if we look at our general equation here, A started single, and it comes in, and it switches with B and kicks it out, and now is replaced. All right? So, let's say this is Annie, Bella, and Cody. All right? Cody's like, ooh, look at Annie over there. I'm going to kick Bella to the curb, and I'm going to take Annie. And look, here's Bella all sad by herself. All right? And Cody's now with Anna. So here's your example. Jennifer Aniston, right? We switch out. She comes in. He's like, ooh, looky there. I'm going to get rid of Jennifer Aniston. And now they're all sad and lonely. Single replacement. Something is left single and sad. All right? They're split up. Now they're all lonely by themselves with a box of chocolate. All right? So, here again we see iron. When it gets wet, it creates iron oxide. That's your rust. All right? That's what happens. That's how things rust. And it just starts to eat away. That's why the metal disappears. Is because now it's no longer just an iron metal, it's iron oxide. It's starting to go away and corrode. All right? So one element switches, something is left. Your keyword is what? Single.
So something's always just gonna get left behind.
Something gets left behind. Yes. Somebody's
And then
replaced,
on
they
the
move on to something better.
On the quiz and test, we'll have to like identify each of these.
Yep, so you would see this and you would say, what happens?
Yeah.
All right, notice the metal always replaces the metal. But somebody earlier was like, but hydrogen's not a metal. Good point. It's not, but what is our charge of hydrogen?
0,
One.
1.
1. It's a what, cation or an anion? Cation. So remember, hydrogen's our little eyeball based on its valence electrons. It's over on the left side. And so your cation is replacing your cation. Typically metal and a metal.
What gets left behind in the example?
In the example, hydrogen. Notice hydrogen doesn't have a buddy. Hydrogen's singled alone.
Okay.
Jennifer Aniston is hydrogen. That's hydrogen's face, if you could see it. All right? It's like, oh no, you left me. All right. So, then we have double replacement. Well, if single replacement, something was left single, what do you think's going to happen in double replacement?
Everything is fine.
Nope.
2 things get.
They both replace. They still are together as a compound, but they both just swap partners. All right? So, ions trade partners of precipitate forms. What is a precipitate? It's when you pour two liquids together and you end up with a solid in the bottom. Right? So, something is rearranged, something wasn't soluble anymore, and so a solid forms in the bottom. So, your general equation here, that's just kind of the basis for what's happening. A and C switch. It's always your metal with your metal, or if you're somebody who switches the end, you just need to make sure you switch the end with the end or the front with the front. We don't want to put two non-metals together, and we don't want to put two metals together. You got to make sure it's a metal and a non-metal. Because what are ionic bonds made out of? What are ionic bonds made out of? Metal and non-metals. All right, so here's your example. You can see the bold ones are what switch. All right, and so it's written the other way, but if you see it, here's these two guys are with different partners. It's written to where you would be able to see the anion switch, but either way you switch it is fine. All right, so here's your example, going old school. All right, Selena and the Jonas Brother and Miley and Justin Bieber. Our two metals have to switch. Remember I said you have to switch the metal with the metal. We can't switch the metal with the non-metal. Because what happens if we do? We switch the girl and the boy. Do we want to put the two boys together?
No.
Do we allow that? No, that's no good. So, if you switch the wrong things, I'm going to say you put the two boys together, go back and fix that. We can't put the two guys together. All right? So, that could be your little reminder key of why you have to switch it. We don't want to put the two guys together. We need to make sure we switch it the right way. All right? So, questions on this one? All right. So, what is the difference between double and single replacement then? Single, what?
Single is like one element and like being switched, and double is both two compounds being switched around.
Yes, good job. Great explanation. So single, you have one element and it gets switched around and something else is by itself. And in double, I have two compounds that I start with and I end with two compounds. Look, everybody, I've boxed in their partners. They all have a partner. They all have a buddy. Nobody's lonely. All right? Good job, Bryce. So the last one here, there's no fun celebrity example for this one. We have combustion. Right? We talked about this the other day. We talked about fire and what fire produces. So combustion, a hydrocarbon, which wood is a hydrocarbon, just essentially means a carbon with a hydrogen. All right, is going to react with oxygen because what do you need in order to fuel a fire? Oxygen. If I put a cup over a match, is it going to continue to burn? No, I've cut off its oxygen supply. So combined with oxygen will then produce, what does fire produce? We talked about it.
Water.
CO2.
Water and CO2. Dirty air and water. H2O and CO2. So that's what's produced when you burn something. Well then why when you're out roasting marshmallows do we not see a wet puddle after all of our wood is burned away?
Because it's not. Why?
Because what?
Yeah.
Go for it, Ben. Evaporates, yes. Alright, because it evaporates, it's let off as steam. Is evaporation a physical or chemical change?
Physical.
Physical, good job. It's still water, it's just in the air instead. Alright? So think about combustion starts with CO, and what do you end with? CO2. But that's not the only thing you can look for, but that just helps get you started. Oh wait, carbon dioxide, and then you should know water, right? So if you see oxygen, carbon dioxide, or water, it is automatically combustion. There's no other, you won't see it producing anything else. Are we good to go to the next one?
Yes.
I'll give you a second.
Is this all we're doing here?
Don't ask that during a recording.
Yes.
Really?
So combustion means
What is-
to have both make a different chemical.
Combustion is something catching fire.
Oh, okay.
It's combustible. It's
Flammable.
flammable. It's
Why
burning.
didn't you say HC for hydrocarbon? Never mind.
Hydrocarbon. That's just how it's. Carbon is your most
We've heard it for a while.
electronegative element, so it comes first, and then your hydrogen. We'll talk about that when we get to Unit 7. All right. So I'm gonna put up 10 different equations, and we're gonna go around the room, and you all are gonna tell me what they are. We'll start with the 4 of you on line. All right, Bailey, you're gonna tell me the first one. What is this? Which type of reaction?
Is it double replacement?
Yes, good job. How'd you know it was double replacement?
Because they traded and no one was left alone.
Yes, they traded and nobody was left alone. Great job. Andrew just gave you the applause. Great job. I didn't even know that was a thing on Zoom. Great job. I love it, Andrew. So both of them started out as a couple, and then they traded partners, and nobody was left alone. All right, great job. Double replacement. Cameron, the next one. Look at what it's producing.
How do you say it?
Co-
Combustion?
Combustion.
Combustion.
Good job. Combustion. Yes, combustion. Because I'm producing CO2 and H2O, and I started with oxygen and a hydrocarbon. So one thing you can look at to remember that is in combustion, look, CO2. All right? Reminds you, oh, wait, I'm looking for CO2, and I need water. You need both of those things. Great job, Cameron. All right, Andrew. Next one.
Is it single replacement?
Yes, great job. How'd you know it was single replacement?
Because one of them was swapped and the other was all by itself.
Yes, great job. Somebody was left all alone and sad and single. All right, great job. Single replacement. Any questions so far? Good?
Wait, the first one we did, is that single replacement or double replacement?
The first one was double because nobody was left alone.
Okay.
Yep. Dare flip your page over. Flip your page, and these are all in your packet. Flip your page, guys.
Oh. What?
Flip your page. There you go.
Wait, so which one is this?
This is the third one. Just pick up where we're at. Pick up where we're at. Single. Third one. All right. Now we're going on to the fourth one. Faith, what is our fourth one?
Is that double replacement?
Yes, good job. Why is it double?
Because nothing's alone.
Nothing's alone. Yes, there was a replacement that occurred, something switched, but nothing was left single. So your CA and your MG switched partners, but nothing was left single. So double replacement. All right, are we doing okay? Now it's those of you in class's turn. Derek. Two things come together as one.
Synthesis.
Synthesis, great job. They synthesized together two, look, you had two separate things that formed one product. Synthesis. Bryce. You asked me about this one, this is why I called on you. One thing breaks up into many.
That's decomposition.
Decomposition, yes. Decomposition. Good job.
Wait a second, but where did that 0 come from? Or where
The
did that
O?
come
It's look, there's three of them here. So you have one here and two here. They just split apart. It goes into different places. They still have the same amount. Good question. Good question. You're prepared for our next lesson, that's for sure. All right, Brecken. You're starting with the right word. Starting with the right letter. Single replacement. Why? Because something, look at it, something started single and something else ended single. So aluminum came in, kicked H out of the way. All right, Allie came in and kicked Hannah out of the way. And Clarence was like, ooh, look at Allie, I want her instead, right? Kicks Hannah to the curb, and now we have Allie and Clarence together. All right? Single replacement. It's the only CL male name I can think of. Yes, Clarence. No, it was a made up story so that you could see somebody's left single, alone, and sad. All right? Clyde, yes. Could have done that. All right. And then H3H2 plus N2 yields 2 NH3. Aaliyah.
Double?
How many products do I have?
3, or is that 1?
How many, do you see any plus signs?
No.
No, so how many products? Only one.
So it's synthesis.
Yes, two things come together to form one.
Where did the 3 go?
The 3's just there to balance it out.
Oh,
Right.
Can you go back? All right. So it's 3H2. So like what?
So that means, good question, okay? Here's a H2,
Yeah.
right? That's two hydrogens together. So 3H2 just means this is what it looks like. Okay? Then I have a N2, which just means I only have one of them. Here's N2. All right? And it yields, y'all are asking good questions, 2 NH3. So, here's an N, and here's an N. All right? And I have H3. So, here's one NH3. And here's my, so I've got two of them. So, here's two NH3s.
wouldn't that be 6?
So now, yes.
I get it.
So here's, I started with 6 hydrogens. Did I end with 6 hydrogens?
So it's distributed property. Like
Yes, that's what your coefficient is doing. All right, nitrogens, there's 2 nitrogens still. It's just balancing it out. All right, I couldn't have created this without 3 of those H2s. All right, good question. That's what our next part's going into. Let's see, Lowell.
Decomposition.
Decomposition, how'd you know?
Is it separated?
It's separated. Great job. And Ben.
Composition.
Try one more time. Combustion. Yep. Combustion. You were starting it right. You just said it wrong. Yes, combustion. I see oxygen, carbon dioxide, and water.